Unit 6 Study Guide, Part 2, Number 9. Sonia wrote each letter of Ledbetter on a separate index card and put the cards in a box. She picked one letter at random, put the card back, that's the important part, she put the card back, and then repeated the experiment. If she performed this experiment 90 times, what is the best prediction for the number of times that Sonia will pick a T? So the first thing I need to do is find out the probability of choosing a T. What's the probability of choosing a T? So how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 letters. And how many are T's? 2. Now I need to set up a proportion. So if I run that experiment 90 times, how many will be 2? So it's 20. How did you get that? Yep, that's one way to do it. What happens if that doesn't work well? Cross multiply. And I could have said 90 times 2 is 180. 180 divided by 9 is 20. 2 ways you could have worked that problem. All right, any questions about that one? All right, let's look at number 10. Caslam's Video Store has received a shipment of DVDs. The table below shows the number of each type of DVD in the shipment. So I look, there's 12 action, 3 science fiction, 6 comedy, 9 western. So what does this mean right here? What did I do and what does this mean? Okay, I add them all up and I found out there are 30 DVDs in all in the shipment. Caslam selects a DVD at random from the shipment. What is the probability that he chooses a western? So if there's 30 in total, how many westerns are there? 9. And then I would simplify that and divide numerator and denominator by 3 and get 3/10. So as I look over here, what looks like the right answer? It's D. 3/10 is not there, but the unsimplified form is 9/30. So your answer is D. If 3/10 was there, which one would you have chosen? Yes, if 3/10 and 9/30 are there, 3/10 is more correct. 11. Joe has a bag containing 8 red sweets, 9 yellow ones, and 11 green. Let's see. I want to do this on a separate sheet so we can try this the way we did the homework. He takes out a sweet and eats it. Then he takes out a second sweet. So are these independent events or dependent events? They're independent because he's not like taking a bite out of one and putting it back. And so these are independent. They're dependent events, right? Because he's not putting it back. What is the probability that both the sweets are red? So let's look. How many are in the bag in total? There's 28 in total. So let's find the first probability. What's the probability that the first one is red? 8 out of 28. Okay. Now that he's eaten one, how many are in the bag? 27. These are dependent events. And now how many red ones are in there if he's eaten one red one? 7. Now there's 2 different ways you can do this math. You can just multiply the numerators together, multiply the denominators together, and then simplify, or what's the easier way? multiply both fractions together on your calculator. Okay, on and clear your memory. And we're going to say 8 fraction 28 times 7 fraction 27. And your answer is 2/27. And that can't be simplified any further. 2/27 probability that both sweets are red. Remember, word problems need to have words in the answers. Jill is playing a game with a spinner like the one pictured below. If the sections are congruent, what does congruent mean? Same shape, same size. And that's important that they're the same size. That makes them fair. Same shape, same size. If the sections are congruent, what is the probability that on Jill's next spin, the arrow will land on a section labeled red? So, what's the first thing I need to find out? How many sections are there? I'm going to put a number. I'm going to count with a number to keep track. There's 16 total sections, and how many are red? There's 1, 2, 3, 4. 4/16. Can that be simplified? Divide numerator and denominator by 4. And you get 1/4. Not read, red. Did you find the 16th one? Okay. Ralph recorded the outcomes he got when he rolled a die 45 times. If Ralph rolls the die 300 more times, how many times would you expect the die to land on a 2? Explain why you picked your answer. So he rolled it 45 times. And what's the probability that what's the experimental probability he landed on a 2? 4 times. If he ran it 300 times, what's the probability he's going to land on a 2? What's the math? 300 times 4 is 1,200. So 1,200 divided by 45. And you get 26 6/10 repeating. Can that be an answer for the number of times you roll? No, what do I need to do? You have to round. What would I round that to? Okay, that's what you need to explain. Round to 27 because you cannot round a fraction of a time. Alright, we have 2 problems left. Tracy has an attendance rate of 97.2% for the school year. What is the likelihood that she will be at school on Tuesday? Is it certain that she's going to be at school on Tuesday? No, even if she had 100% attendance, it would still be, I don't know that you could say it would be certain, but it would be very close. So I would say your answer should be likely or very likely. Likely or very likely. It wouldn't even be 50-50 because it's a lot higher than an even chance. So I would say likely or very likely would be a good answer. Your last one, design a spinner that meets the following requirements. You have to have these three things. There has to be a 25% chance of spinning a 1. You need to be more likely to spin an even number than an odd. And there's at least 4 sectors. Now, the one thing it doesn't say that I looked for was that it needed to be a fair spinner. Each section had to be congruent or the same shape and same size, and it didn't say that. So that gave me a little bit of freedom. So this is what mine looked like. The first thing I was going to think about was, how do I show 25%? So I knew that 25% is the same thing as a fourth. So I split it in half first. I split it in half. And then I split that in half again. Because half of a half is a fourth. So I knew that my 1 is 25%. And then it said I needed to be more likely to spin an even number than an odd. So this is even and this is even. And you see how these are larger than the 2 odds? So that makes them more likely. And then the last, it needs to have at least 4 sectors. And do I have 4 sectors? Yes. So that's how I chose to draw my spinner. There's a lot more options than that. Then it says, then explain why your spinner meets these 3 requirements. So I said the 1 sector, the first sector is half of a half, so that equals 1/4 or 25%. The sectors for 2 and 4 take more room than the sectors for 1 and 3, so it makes them more likely. And then there are 4 sectors. Those are my explanations for how I made sure that they followed all 3 requirements.